So here's a situation that many of you know. How do you get your Gen AI pilots to production faster? And it's usually the data security and privacy concerns that are blocking your teams. Without addressing those, your end customers are never going to see the value of the app your team is building. And this is where OWASP comes in, because they've done a really good job of providing guidance on what are the issues you need to be fixing. And in the next 20 minutes, I'm going to talk through a simple 5-step framework that teams can leverage to build applications in a secure way, aligned with the OWASP guidance. The goal really is to help your organizations build these AI applications faster, safer, and with lower stress. So within your organization, there are really 3 areas where AI is being used. First is internal application. A lot of experimentation happening. There's shadow AI. Central teams do not know what kind of applications are being built and whether they are guardrails or not. If you look at it the developer perspective, many experimentation is happening. And developers know that, hey, while building LLM apps, their systems, tools, and processes haven't caught up. So they don't have the guardrails ready to build applications safely. And the third area is, as organizations, we know that, hey, an easier way to harness the value of Gen AI is to use it in SaaS apps, like co-pilots. But again, to use those apps, you're exposing your sensitive corporate data, which also brings in security risks. So it's all 3 areas where you need the right level of visibility and control, and we'll talk about an approach that addresses these. Now, most of you are familiar with the OWASP list. What you have also noticed is, earlier this month, OWASP came out there with 2025 list. There are 3 things that are new. One, the number 7, system prompt leakage, is a new vulnerability. The vector and embedding weakness is also a new one. And the last one, unbounded consumption, has changed. But the question is, of this top 10, which one of these vulnerabilities should you worry about most? And most people that you ask will talk about prompt injections because that's what they've heard about, and that's the most common newest attack. But here's a slightly controversial take. I think the most important ones are number 2, sensitive information disclosure, and number 6, excessive agency. Why? Because the attackers are after sensitive data, and the second one, excessive agency, is about fixing entitlements, which is very challenging to fix in an LLM-based application. And we're going to talk about all of these today. Here's the other thing I like about OWASP, right? This is a sample architecture that they share in this research. And what they're telling us is, to secure your application, you need a holistic approach. What does that mean, right? There's a common myth that AI security is about prompt security. You can just put a firewall on the edge, analyze your prompt, and then your application is protected. But if you really try to dig into this architecture, what you'll notice is, in the middle you have the models. At the bottom, you have your data, right? The training and fine-tuning data that you have. On the bottom right, you have your corporate data that you're using into the RAG pipeline. On the left-hand side, you have the prompts coming in, the responses going out. And on the top side, you have the different components like plugins, right? The key thing to notice here is the red boxes. These are the vulnerabilities. And as you can see, they are spread across the entire application. They're not just on the edge, on the prompt. So to truly secure your application, you need to think about a holistic approach, where you need to first understand the data flow. How is the data flowing in? Where is it coming from? How is it going to the model? Are there entitlement controls? And if the interaction that is happening beyond the prompt, is the retrieval secure? Is the response secure? So you need a holistic approach to protect this. The other critical aspect, which is really blocking teams, is lack of unstructured data governance. So if you look at last 10, 15 years, what has really happened is, our organizations have become mature when it comes to structured data governance. We have built data catalogs. We have enabled our teams, our data science teams, to safely access structured data so that they can build predictive machine learning models. But on the unstructured data side, security approach has primarily been defensive. We want to protect that data from breaches. But nobody has tried to harness value out of that data because there has been no technique to do that. Now, Gen AI brings you that opportunity that you can analyze unstructured data. But what teams are struggling is, hey, we are caught off guard because the data itself is not secure. You don't know what sensitive information lives in that data. Is the data quality good? If you're going to feed garbage data, you're going to get a garbage response out of an LLM, right? What about the sanitization and entitlements of data? So the whole unstructured data governance becomes a critical activity, which is foundational to building these applications in a secure way. So now let's start thinking about, with these issues, how do you think about building your application securely, not just an individual app, but the organization level? So the number one question that you need to ask is, okay, where is AI and especially LLMs being used in my organization? What models and agents are being used? And what risks are they exposed to? The second question you need to ask is, what data is being exposed to these models? And this is a complex problem that I'll talk about in a moment. Now that you have the picture of data in the models, you need to think about what are the holistic set of controls that I need to put in place to mitigate all those risks. And lastly, compliance has to be a byproduct, right? If you're doing your controls correctly, the application should automatically be compliant with various frameworks that you care about. So kind of how do you mitigate these risks? Let's start one by one, a 5-step approach. Step one is really about automated discovery. It is about discovering what models and agents you are using. So as an organization being in AWS Show, your developers may be hosting models in Bedrock, right? Picking a number of foundational models that are available there. Or they may be using SageMaker to tune their models, or maybe hosting on EC2 infrastructure powered by NVIDIA GPU. Whatever the mechanism, there may be hundreds of these apps being built. You need to automatically discover where is my development happening. Then you also need to look at the underlying infrastructure side, right? And this really becomes critical. So that's your cloud infrastructure. What about your SaaS applications, which also have AI embedded? Many of our clouds are now redoing their contracts with the vendors, and they're doing third-party assessments, asking your vendors, hey, what kind of AI you are using and what is my risk implication? The ultimate output is you need to take all of this automated discovery and put it as a central catalog. That really is critical for understanding your supply chain risk. As we say, right, you can't protect what you don't know. So this becomes critical to know what models are being used, and that kind of feeds into your next step, which is model risk assessment. Now the reality is, most of our organizations are not building our own models. We are picking something off the shelf, which means that we are going to be inheriting many risks. Across these models, there are many issues we need to worry about. Toxicity issues, their vulnerability to malicious attacks, biases that are being built in, their vulnerability to hallucinate in many different scenarios, right? So you need to assess these models, and there are many benchmarks available. So what we help is, through a model card, you can compare different models and look at the risk score. And you need to give that information to your developer teams. So as they are building that application, they can make an educated call, hey, based on the risk rating, is this model the right model that I should be using for my use case? If not, what flexibility do they have to switch the model that gives them a better performance or better fit for the use case? The other aspect is, aside from the model risk, you also need to think about the infrastructure risk. Infrastructure that is hosting your model. Again, these become critical because model is a part of supply chain that you're bringing in, right? You're not training these models. And they may be, if the infrastructure is not properly secured, these models are again prone to poisoning attacks. And if they hallucinate, they can give the wrong false information. So a number of OWASP issues become critical here. The third step is about understanding the data. Now, as you can imagine, right, we are still in that phase. We are trying to understand what is my risk. We haven't started building controls yet. In this step, what you need to really understand is what data is being used by my application. And the reality is, one model is going to be feeding in data from many different data sources. And similarly, one data source is going to be feeding in information to many different models and pipelines that your organization is building. So very soon what you realize is, in your company, you have these hundreds of AI pipelines and these massive permutation combination of data being used by different models. So essentially what you need is a knowledge graph so that you can understand what is your data exposure. Within that, you need to understand context. What kind of data am I feeding? Is there anything sensitive in that data? What are the entitlement issues I need to worry about? And I'll talk about why that is critical. Is there any redundant data that's built in, right? So you need to have an understanding of your data risk. Why? Again, critical to understand, are you vulnerable to sensitive information disclosure? If your data infrastructure, let's say, is publicly exposed, somebody can go in and corrupt your data sources. Or maybe your organization is using some public data set which is poisoned or it has biases built in. So you need to understand your supply chain from a data perspective, right? Entitlements become critical because you need to understand your excessive agency problem. So till this step 1 to 3, you're really trying to understand what are the risks you're vulnerable to. In the next step, now you need to start thinking about controls that you need to put in. And we break down these controls into 2 buckets, the data level controls and then the model level control. On the data side, the number one thing is sanitization of data. If you're worried about your sensitive corporate data getting exposed to an application, the best way is to not feed that data. So you need to automatically classify your regulated data, your confidential data, and redact it or mask it before it's feeding to a model or going into a vector database. The second control that you need to think about is entitlements. Now this is a really challenging problem, but a critical one to solve. In order to fix the entitlement issues, you need to first start with the data source entitlements. If your data source itself is widely accessible to users, no application can protect that, right? Any user who is using that application will be able to access that data. But let's say you fix the underlying data source entitlement. That's step one. Your models can still bypass those controls. So what we are hearing, the challenges many organizations are running into SaaS copilots is like employees seeing data by using LLMs, the data they don't have access to. Why is that happening? Because models are not honoring the underlying entitlements. So when you design these entitlements, the models need to take into account when they're generating embeddings, whose data is it? And if the person asking the question about data is not entitled to that data, model should deny access even through the application. So entitlement becomes critical. So as you kind of think through this, sensitive information disclosure is a key aspect you can mitigate by sanitization. Excessive agency becomes mitigable through the entitlements, right? Vector and embedding weaknesses, right? If you're not feeding sensitive data into your vector DB, and if embeddings don't contain sensitive data, you're building a defense in depth strategy there. The next layer of control is when you start thinking about the firewalls, right? And firewalls are not something just you put around the model. There are multiple layers. So what kind of a firewall you need, right? It's not a network firewall. You're not analyzing packets. These are conversational firewalls because you're trying to understand human language, different languages, the prompts that are going in and responses that are going on. And these firewalls need to be context aware. So if these firewalls understand the kind of data you're trying to protect, they'll give a better throughput. So you really need to put firewalls at least at 3 levels. One, inspecting the prompt, the question that is being asked from the model. Second, inspecting the retrieval of data, the context that the vector DB and embeddings, basically your knowledge bases are providing to answer the prompt. And the third is response that's going on. So how does it help? So the number one vulnerability that you worry about is prompt injection. So through a prompt firewall, you can look for, let's say, jailbreak instructions, right? That can help you mitigate a direct injection attack. Or maybe you can look for a malicious URL embedded into a prompt to mitigate indirect injection attack. Similarly, you can also kind of see rate limit. A prompt firewall can rate limit and see, okay, hey, if there's a number of repeated requests coming in, that can mitigate denial of service attack, which is your unbounded consumption. Now, as you start thinking about retrieval of data, maybe a sensitive data packet is being retrieved from your vector DB. Then it helps you mitigate the vulnerabilities in the vector databases. If somebody corrupted it, you can still leverage the response firewall and put a policy to say that, hey, my embedding should not contain, let's say, source code information. The third area is you're analyzing the response. So let's say a popular example is one of the auto dealerships built a customer-facing chatbot to give clients information about the inventory of cars. But students actually got access to that chatbot, and they were using that chatbot to write source code and write their essays, right? That's a simple abuse of application which is costing you. Now the response firewall can see that, hey, the kind of content that's being generated, is it in line with the use case that the application was built for? Is it in line with my company policies? So as you can see, these firewalls can help you mitigate a number of issues, including improper output handling or even preventing generation of misinformation. So now let's see how some of these controls help, right? Here's a simple application pipeline that we have built. What you're seeing here is entire provenance of your AI system. On the top, you have your data, which is the files, unstructured data that contains sensitive information, as well as users who have entitlement, and those entitlements have been corrected, right? As you can see, this data is being loaded, and it is being sanitized before being fed into a vector database, right? And this vector database is actually now connected to a model. And we are giving developers flexibility. They can pick and choose whichever vector DB they want, whichever model they want based on their use case, right? And on the right-hand side, you have your different firewalls, right? So once you build a pipeline like this, let me give you a few examples of how the controls can be implemented. So here's the first example, right? Let's say you have an internal chatbot and you have a marketing person going and asking information about what is the average salary of my employees in US, right? There's no reason why the marketing person should be given access to that data. With the entitlement controls built in, that the pipeline is going to honor and not give them information. But when the HR team goes and asks the same question, you actually get the data. You get the average salary, but you also get the citation information, right? This is the benefit of imposing entitlements right into the pipeline. Here's another example. So let's say you have minutes of the board meeting which contains sensitive information around earnings call. So if a user is asking that, hey, I want to know who attended that meeting, right? If the response firewall is off, you are essentially exposing, as a response to that question, all the PII, which is ideally not the right thing to do. But once you turn on the firewall, right, it can actually automatically block PII. When the same question is asked, it's not going to generate the and give PII information out, right? So these are just some live examples of how you build in these controls. The last piece is compliance, and very, very critical, right? Many of us in different organizations care about different framework. Those in US maybe care about NIST AI RMF. You care about different data regulations. In Europe, you care about EU AI Act, right? The important piece is the compliance should not be a checkbox exercise, right? It's not a paper assessment that you do at the end of building the application like, hey, I followed these policies. Because the reality is these frameworks are asking you to build these same controls. So let's say if you're doing classification of data, or if you're doing sanitization of data, there are many controls within these frameworks that you have already checkboxed. So when you are building these security controls, compliance has to be an automated byproduct, right? You should automatically see along with your application, what is your compliance assessment? And what is your risk score, right? Where are the gaps? So compliance really needs to be tied into security control, and it has to be an automated byproduct. So let's recap all the 5 steps, right? The steps 1 to 3 are about visibility, which is about bringing all of your internal applications and SaaS applications into governance, whether it's your shadow AI or sanctioned AI projects. So you start with the visibility into what models you have, you assess the risk of the models and agents that you have, and then you understand what data is being fed to those models, right? It's all about risk assessment. In these phases, you're really learning what are the issues you need to fix from an OWASP standpoint. And then you put in appropriate controls on data and the model, which is essentially sanitization, which is around entitlement, which is around analyzing the interactions, which is prompts, response, and the retrieval of data. And finally, the compliance has to be automated. So now this brings us to why are we talking about this, right? At Securiti, what we have really built is a data command center platform that really allows your teams to build these AI pipelines within minutes. Literally, as a non-developer, I can go in and build this system, this LLM-based application in 10 minutes, picking data from any source, feeding into any model, and building these security controls. So if you would like to learn more, I would recommend you scan this URL. And with this, we'll be sending you all a demo video so that you can see live how these controls can be implemented. Alongside that, you'll also be getting access to these slides, as well as free access to one of the top 5 AI security and governance certifications for your entire organization. So please scan that URL. And if you have many questions about this framework, please either meet me after the session or visit our booth 1794 Security AI. Thank you very much.